William Bell's Atoms and Stuff. What is an atom? Atoms are the building blocks for everything we know in this world. They are tiny and impossible to see with the naked eye, although can be seen through powerful microscopes. It is these atoms that determine different elements and the type of the different materials that are found in this world. Elements are made of three distinct particles: protons, neutrons, and electrons. An electron has a negative electrical charge, a neutron has no charge, and a proton has a positive charge. Both protons and neutrons have an atomic mass of 1, and electrons have an atomic mass of a number far smaller than 1. The structure of an atom, according to the Bohr model, is where the protons and neutrons are stuck together in the middle. This is the nucleus of the atom, and the electrons orbiting around the nucleus. The element I have chosen to use as an example is copper. Copper is used as a conductor of heat and electricity, as a building material, and as a constituent of various metal alloys, such as sterling silver used in jewelry, copper nickel used to make marine hardware and coins, and constantan used in strain gauges and thermocouples for temperature measurement. Copper is relatively soft compared to other metals. It is malleable, which means it can be bent into shape without breaking. It is ductile, meaning it can be drawn out into a thin wire. It has high thermal conductivity, which means it can conduct and store heat easily. It has a high electrical conductivity, which means electricity can easily pass through it. Copper also has a really attractive reddish-orange metallic luster. This is what copper looks like on the periodic table. In the top right, we can see the electron configuration. This tells us how many electrons are in each electron shell of the atom, being 2 in the first shell, 8 in the second shell, 18 in the third shell, and 1 in the valence or outermost shell. Above, we can see the number 29. This is the atomic number, and it represents the amount of protons in the nucleus of the copper atom. This number will always be copper specific. The two large letters, a capital C followed by an undercase U, is the chemical symbol for copper. We have the name of the element, and lastly the atomic mass, which is the overall weight of the atom including protons, neutrons, and electrons. This is what an atom of copper looks like. In the nucleus, we can see the protons and neutrons. Important to note that the neutrons prevent each proton from repelling away from each other, seeing as though all the protons are positively charged. In the blue, we can also see the orbiting electrons. This is the periodic table. It consists of all the elements that we know of. Bordered in black, we can see where copper sits itself on the table. The position of each element on the periodic table has its own significance and can determine the reactivity of the element. Sorted by columns, the elements are positioned according to their valence electrons. These are called the groups. By rows, the elements are sorted by the number of electron shells. These are called the periods. For copper, it is in the 4th period and the 11th group. It is in the 4th period because it has 4 electron shells. Although unfortunately, copper is one of the few elements that does not comply with its group number and electron configuration. Next, we will talk about how ions and isotopes are formed. As a general rule for all atoms, they are always trying to obtain a full valence shell. As an example, if the element copper lost its one outermost electron, it would then have a full valence shell, and as a consequence of losing one negative charge, it would then become a positively charged ion, also known as a cation. Isotopes are formed when an atom has an irregular number of neutrons. So if this neutron joined our copper atom, we would then get an isotope of copper. So our atom would still have 29 protons, but it would have 36 neutrons. This form of copper could be unstable and radioactive. This could cause the release of particles or decay. The half-life is a measurement that measures how long an atom halves in mass because of this decay. Atoms have different half-lives ranging from hours to years. One form of radiation is the expulsion of an alpha particle, which is a clump of 2 protons and 2 neutrons. Due to its relative size, it can easily be stopped by a few centimeters of air. Another form of radiation is the expulsion of a beta particle, which is just a single electron. This can be stopped by a piece of paper. The final form of radiation is the release of gamma rays. These rays can be stopped by thick lead or concrete. It is this type of radiation that is the most harmful to humans, as it can damage DNA in our cells. Lastly, I would like to talk about chemical reactions. A simple reaction for copper is its reaction with oxygen to form copper oxide. This is the word equation for this reaction. And this is the balanced chemical equation for this reaction, where there are 4 copper atoms bonded with 2 oxygen atoms to make 2 compounds of 2 copper atoms and an oxygen atom. On an atomic level, a reaction could occur because of the sharing of electrons. This is called a covalent bond, or the donation and receiving of electrons, which is called an ionic bond. Because of the changes in electrical charge, the atoms become electrically attracted to each other. I now model an ionic bond forming after a chemical reaction between copper and oxygen.